Okay, we're going to talk about factoring. First, we got to look at what standard form is when we're talking about polynomials. So ax squared plus bx plus c is your standard form with polynomials. So when we're factoring today, we're going to factor whenever this number is 1. So that means we're not going to see a coefficient on x squared. In order to do this, we need a kind of refresher on factor puzzles. This is something you guys did last week on your playlist. So with a factor puzzle, we make an x. The top number is a product, so it's a answer that you get when you multiply two numbers together. We're using a and c to come up with this number to start with. So a and my polynomial and c, we multiply them and write that number. And then the bottom number comes from the coefficient b on x. We use those two numbers to then figure out what two products would add to get the bottom number. Let's do a few practice. So let's go through and look at 12. We want to write all of the factors of 12. I always start with 1 and do 12 divided by 1, and then 2, same thing, and just keep going until you hit a number that's already in your list. So our factors are 1 and 12, 2 and 6, 3 and 4. When I take a look at those, the ones that add together to get my sum of 7 are 3 and 4. So I'm going to put 4 and 3. Go ahead and try 2, 3, and 4. Just pause the video. All right, so let's take a look at 2. You should have listed factors of 9 as 1 and 9, 3 and 3. The two factors that add together to get 6 are 3 and 3. For number 3, factors of 18 are 1 and 18, 2 and 9, 3 and 6. The two factors that add together to get 9 are 6 and 3, so we put those in the puzzle. And then for number 4, 24, our factors are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. The two that add together to get 12 are not actually listed here. We don't have factors that add together to get 12, so this is not possible. All right, so let's take a look at 4 more. Go ahead and try number 5. Pause the video, and then we'll go over the answer. All right, so factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. We need two factors that add to get 13. Those are 10 and 3. Taking a look at number 6, we have a negative product. So to get a negative product, we have to multiply a positive times a negative. And then our sum, when we add a positive and a negative together, is negative. So that means the larger number out of our two factors is going to be negative, and the smaller is going to be positive. So I always like to put my larger number on the left and my smaller number on the right, just so I have some kind of order. It's not going to change anything if you switch sides, just be careful with the signs. And then once we do that, we just list our factors of 24. So we've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. What I do now is I type these numbers into my calculator, with the larger being the negative and the smaller being the positive. So I do negative 6 plus 4, see if that gets me negative 4, and it doesn't, it gets me negative 2. Then negative 8 plus 3 does not get me negative 4, it gets me negative 5. Negative 12 plus 2 does not get me negative 4, it gets me negative 10. And negative 24 plus 1 gets negative 23. So none of these pairs of factors work. If we were to switch them and make the smaller ones negative, you would end up getting positive sums. So there is not a solution, or it's not possible to do this factor puzzle. Taking a look at number 7, again, we've got a negative product, so it's a negative times a positive, but my sum is positive. That means the larger number is going to be positive and the smaller factor will be negative. And then we look at our factors of 15, which are 1 and 15, and 3 and 5. So we take a look and we put our bigger number as positive in our calculator and the smaller factor as negative. So we do 15 plus negative 1, and we see we get 14. And then just to check, 5 plus negative 3 does not get us 14. So we're going to put 15 as the positive and 1 as the negative. Okay, the last one, we've got a positive product but a negative sum. So to get a negative sum when you have a positive product, that means you're multiplying two negatives to get that positive product. So each of your factors should be negative. And then we list our factors of 28. So that's 1 and 28, 2 and 14, 4 and 7. When I type these into my calculator as both negatives, -4 and -7 is -11, -2 and -14 is -16, and -1 and -28 is -29. So none of these factors will get you a sum of -2. So this puzzle is not possible, or you cannot complete it. All right, so the purpose of this was to practice using these factor puzzles so that when we get to factoring polynomials, you can use the puzzle to start factoring that polynomial. Let me go ahead and give you an idea of what we're talking about. So if you flip over to the back of your notes, the first step is we're going to create that factor puzzle. So remember, the factor puzzle is from a polynomial, so ax squared plus bx plus c. It has to be in that form. The only thing that can be missing is the bx, and you can still use the factor puzzle. If you're missing the c value, the constant, then you're not using a factor puzzle to factor that polynomial. We'll talk about what step you would start on. So remember, our factor puzzle is our x. To get our top number, we multiply a and c together. To get our bottom number, we write b. Don't forget about the signs in front of the numbers as well. So we're going to use that factor puzzle. And then in step 2, we're going to take that factor puzzle and the numbers that are written in our answers, we're going to use to split up our bx term into 2 terms. So those 2 terms are going to be using the numbers from the factor puzzle. So let's take a look at what I'm talking about. If we look at example 1, I'm going to do a factor puzzle off to the side. My a is 1, my c is 6, so 1 times 6 is 6, and then my b value is 5. If I write my factors of 6, I have 1 and 6, 2 and 3. The ones that add together to get 5 are 2 and 3. So that's my factor puzzle, step 1. Step 2 is taking my bx term, that's the term in the middle, and I'm going to split it into 2 terms that add together to get me 5x. So the first term is going to be 3x, the second term is going to be 2x, and I put a plus sign between. Again, I got the 3 and the 2 from the factor puzzle. Those 2 numbers are your coefficients of your 2 terms when you split 5x. Then we just bring everything else down. So the plus x squared in front and the plus 6 behind. Okay, after that, step 3 is to then create 2 binomials using grouping symbols. That's why I have parentheses around binomials. And then we're going to factor out a GCF from each of those binomials. So taking a look at our example, we're creating groups. Our groups are always going to be the first 2 terms, the plus sign in between, and then the last 2 terms in a group. So my first group is x squared plus 3x. My second group is 2x plus 6. And the second part of step 3 was finding a GCF. So when I'm looking in each of these groups, I'm just going to cover up the second group and look at the first one by itself. I look for numbers first. So my coefficient here is 1, and my coefficient here is 3. Their GCF is 1, so that doesn't work. And then we're going to look at variables, x squared and x. Your GCF, when you're looking at variables that have the same base, is always the variable with the smaller coefficient. So x squared and x have the same base. X to the first has the smaller coefficient, so that means my factor, my GCF, is x to the first. I'm going to pull that out of my problem, and inside parentheses, I'm going to write what I have left over. The way I figure out what I have left over is I take that GCF and I divide both of my terms by that GCF. So x squared divided by x, we use our quotient of powers rule. I take my exponents 2 and 1 and I subtract them and I get x. Then I do 3x divided by x. So again, x divided by x, 1 minus 1 is 0. That means you have no x's. And then the 3 is being divided by a coefficient of 1, which just gets you 3. So we've got x times x plus 3. X is the greatest common factor. X plus 3 is what we have left over. Then we look at the second group. We bring down the addition first, and then we find the GCF of these 2 terms. So again, numbers first, look at the coefficients, 2 and 6. If I list out their factors, their GCF is 2. So I'm going to pull out 2, and then when I look at variables, my term of 6 doesn't have a variable, so I cannot pull out a GCF that is a variable. 2 is the only GCF here. When we divide both terms by 2, I end up getting x plus 3 inside my group. Okay, so this is what we have. We've got x as the GCF from the first grouping with its remainder inside the parentheses, and 2, which is the GCF from the second grouping, and its remainder inside parentheses. Okay, so step 3 is to then look at those 2 groups that we created and to factor out the greatest common factor of the entire thing. So we're looking at each part and we're seeing what do they have in common, what looks exactly the same. Well, the x plus 3 is in both the first set and the second set of groups. So what we're going to do is we're going to take that group of x plus 3 and we're going to pull it out front, and then we're going to write a second set of parentheses and write whatever is left over that I didn't pull out into that first group. So here I see that there's an x term that was the GCF that's left over. I'm going to pull that down into this group, and then this plus 2 is left over from my second grouping, and I'm going to pull that down here.
Okay, so these 2 groups are our final answer for factoring the original polynomial. Okay, so let's repeat those steps in example number 2. For example 2, we're going to make our factor puzzle. Again, a times c, a is 1, c is 8, goes in the top, and then -6, we take the sign and the number, goes in the bottom. Because I have a positive product but a negative sum, that means I'm doing a negative times a negative. A negative times a negative ends up getting me a positive product, but then a negative sum. So then I'm going to list my factors of 8, which are 1 and 8, 2 and 4. I make both of them negative and then add them together in the calculator to see if I get a -6. So -1 plus -8 is not -6. -2 plus -4 is -6. So I'm going to have -2 and -4 as my factor. So step 2, we're going to use those 2 answers, -2 and -4, to split the -6x term into 2 separate terms, -4x plus a -2x. And then we bring down our plus 8, and then we bring down the x squared, and we want to have addition between every term in my expanded 4-term polynomial. After we do that, the third step was to create groups. Remember, we always group the first 2 terms and the last 2 terms. After we create groups, we were asked to find the GCF. So for my first group, there is no number GCF because my coefficient here is 1 and this coefficient is -4. But I do have a variable GCF. Remember, they have to have the same base. I have x's, and then the lower exponent is my GCF. So this has an exponent of 1, which is smaller than an exponent of 2, which means my GCF is just x to the first power. And then I write in parentheses what I have left over when I divide each term by that GCF. Okay, so my GCF is out here. X squared divided by x is x, because again, we subtract the exponents when we're dividing. 2 minus 1 is 1, so x to the first. And then plus x divided by x is no more x's, so I have my coefficient left over now as a constant, so -4 comes down. I bring down the plus sign, and then I find my GCF of the next part. 2 is the GCF, but we always want to make sure our first term is positive. So we're going to pull out a -2 so that my first term in this group becomes a positive. And then we divide both terms by that -2. So -2x divided by -2 is just x. And then 8 divided by -2 is -4. So we're going to have plus -4. Okay, my fourth step is to see what they have in common when I read this statement. I've got an x plus -4 here and an x plus -4 here. So that is my greatest common factor between these 2 sections. I'm going to pull out that greatest common factor and write it as x plus -4 in parentheses. And then I'm going to take what's left over. Here, the x is left over. and here the plus -2 is left over. I'm going to write those inside parentheses. The last thing I do before I write my answer circled is I check to see if I can simplify. In example 1, I couldn't because it was adding positives. Down here, because we're adding negatives, I can rewrite them as x minus 4 as a group, and then x minus 2 as a group. And then this would be your factorization of the polynomial. Okay, so let's try it for example 3. First step is a factor puzzle. -2 times 1 is -2, and then -1 is our b value, so that goes down here. Because I have a negative product, that means I'm doing a negative times a positive. Because I have a negative sum, the negative factor is going to be the larger number, and the positive factor is going to be the smaller number. The only factors of 2 are 1 and 2. So -2 because 2 is the larger factor, +1 because 1 is the smaller. Add them in my calculator to make sure they get -1, and they do. We take those two numbers and we split the negative x term into two terms, -2x plus 1x, or just x. We bring down the -2 as plus -2, and we bring down the x squared as x squared plus, and then the -2x. Then we go ahead and group our first two terms and our last two terms and find the GCF. So here I have no number that's a GCF, but I do have a variable of x. When I divide each term by x, the first one is just x. The second one gets a remainder of plus -2. Then in my next one, I have no GCF besides 1. Even though 1 multiplied by anything is the same thing, we still want to pull out that GCF so that I know I did it, and so I know there's a number here. And then inside parentheses, we write the x plus -2, because when I divide by 1, they just stay the same. Now I look for the greatest common factor amongst this whole thing. What I see in common is this x plus -2 in both of the parts. So I pull that out as my first binomial. And then in my second set of parentheses, I write the x that's left over right here and the +1 that's left over right here. Okay, so now we have to check for simplifying. So I'm going to take this x plus -2 and simplify it to x minus 2. And then the x plus 1 stays the same. And these are my two binomials. It's the complete factorization of that original polynomial. All right, last example. Example 4. Factor puzzle first. We've got -15 times 1, which is -15. And we've got 2 as the b value. To get a negative product, it's a negative times a positive. To get a positive sum, when I have a negative and a positive, my positive has to be the larger factor and my negative has to be the smaller. Factors of 15 that we can write out are 1 and 15, and then 3 and 5. If I make the bigger number positive and the smaller number negative, 15 plus -1 does not get me 2. 5 plus -3 does get me 2. So we're going to write 5 and -3. Take those and split the 2x into 5x plus -3x. Bring down the plus -15 and the x squared plus. Then we're going to group the first two terms and the last two terms to find GCFs. The first group has a GCF of x. I divide x squared by x and I get x. I divide 5x by x and I get 5. I bring down the plus sign, and then my next GCF is -3. I divide each term by -3 and I get x, and then I divide the second term by -3 and I get 5. Then I look for the common factor. I've got x plus 5 and x plus 5 as commonalities. I don't even know if that's a word, commonality. So we're going to take that x plus 5, we're going to pull it out, and then the remainder goes inside another set of parentheses, the x here, and then the plus -3 here. I can simplify plus -3 to just -3, so we're going to write x plus 5 over again, and then x minus 3. Okay, you're going to try the 4 practice problems on the bottom. and check your answers using the key. When I get back, I'll show you a method you can use to check this answer before you move on to another problem. So right now you're trying the 4 practice on the bottom. I have the answer key up here. When you're done with those 4 practice problems, you're going to pick up the practice page from myself or the substitute.